Hi, this is Mr. West, and today we're doing a Khan Academy tutorial on using units to solve problems. This was a video request by Nikki. It's taken me a while to get to this request, but it's my commitment to try to get to all the requests that my subscribers leave comments on. So I apologize it's taken me a while. I've been extremely busy as of late. But again, this is why I have the channel, is for this purpose. So thanks for requesting the video. Let's get right into it. This exercise right here, before I read this first question, is in this entire Khan Academy exercise is all about deciphering what information you need and what you don't, and then building up equations and proportions to solve these problems once you have the correct information. So let's go ahead and read this first problem. Lennox owns a big apple orchard. She ships her apples to various markets using a fleet of trucks. Every week, each truck goes on 3 trips, and for each trip, Lennox gets $300. On a single trip, a truck delivers 50 packs, and each pack contains 12 kilograms of apples. Overall, Lennox sells $4,500 worth of apples in a week. How many trucks are in Lennox's fleet? If you look at this information, it's overwhelming. So we need to decide what we need. Let's start with the question. How many trucks are in Lennox's fleet? Okay, so we know that if we have a certain number of trucks, we'll call T the number of trucks. Okay, so one of the things we need to know is if we're trying to figure out how many trucks there are, we need some information about the total per week. So we could either go kilograms, okay, but we don't know the total number of kilograms. We just know the total per truck, okay? So that's information we actually don't even need. We don't need to know anything about the apples because we're not given any final information. Here we're said overall, so let me just go back here. We know that there's $4,500 worth of apples in a week. So again, we don't need kilograms. We don't need packs. We just want dollars. So that we have $4,500 in a week, okay? And then how much does each truck make per week? Each week, each truck goes on 3 trips. So we have 3 times, this is each week, okay? And this is 1 truck. And then each trip gets $300. So this is 1 truck here. Okay, this is not our variable, but this is just the rate for one of our variables. So we do 3 times 300, and that gives us $900 per week. Okay, so there's 2 ways we can do this. We can write it like, and then actually it's going to convert, but let me show you. So this is like times the number of trucks times the rate, right? So for each truck, the number of trucks we have, if we have like 10 trucks, we'd multiply that by the rate, and that would equal 4,500. I'm looking up in this top right corner right now. So, oops, there we go. So we could write this as a proportion. I think that's the easiest way to do this. So we know that $4,500 is made per 1 week. Okay, so 1 week, $4,500. And then we know that we have a certain number of trucks, and it has the rate of $300 times 3, so that's $900 per truck because they make 3 trips per 1 week. Okay, once we simplify this, since we're dividing by 1 to both sides, it's going to look like this. T times 900, or of course 4,500 equals 900T. So you can see it's a one-step equation once we simplify. Okay, another thing you could do is you could do like a cross multiplication problem, but in this case, I think it's easier just to do this. So we're going to divide by 900 here, and we get 5 equals T. So there's 5 trucks, okay? 5 trucks times 3 trips each. That's 15 trips times $300, and that will get you 4,500. So we have 5 trucks in this fleet, and that's the way you do this. Again, we didn't need the kilograms. We didn't need the packs. It gave us the total for dollars, so that's the only thing we were concerned about. 5 trucks. Let's move on. Okay. The house Trevor's family lives in has 6 people and 3 bathrooms, okay? In the past month, each person showered for an average of 480 minutes and used an average 72 liters of shower water over the entire month. Water costs 20 cents per liter, okay, or $0.2 per liter. How much did Trevor's family pay per minute on shower water? Okay, so it gives us a lot of information, but we're only interested in the rate here. So we're only interested in the pay per minute. Okay, and it's the family. So we need to total up all 6 people. Okay, since we're only interested in the minutes, this is where we're going to start. We know that there's 480 minutes. Okay, and we want to know the per minute. So we need to know the total amount they spent. So they did 480 minutes. Okay, let's see, each person showered for an average of 480 minutes. So we need to multiply this by 6 for the total number of minutes. Okay, so we do 480 times 6, and that's including Trevor, so we get 2,880 total shower minutes. Okay, we don't care about the bathrooms. Number of bathrooms is irrelevant. Okay, next up, we want to know how many per minute on shower water. We don't care how many liters. Yes, we do. We want to know how many liters of water. Use an average of 72 liters of shower water. Okay. And it's 20 cents per liter. So again, we need to do 72 times 6. We get 432 liters. I think that's the abbreviation for liters. Okay, so 432 liters over 2,880 minutes. Now, we don't want liters per minute. We want how much did Travis pay. So we're talking about dollars, okay? So what we need to do is we need to convert these liters to dollars. Luckily, we have that conversion. We can do 432, I should write this down, times 0.2, and that's going to give us our dollars. So we do 432 times 0.2, or we could just divide by 5, and we get $86.4. Okay? So on water only, this family spent $86, but we need to divide that by the number of minutes. So we do 86.4 divided by 2,880, and we get, give me a second, I wanted to rewrite this, and we get $0.03 per 1 minute. That's not bad. So 3 cents a minute. Okay? Don't tell that to your dad, because then he's gonna time you and tell you how much money you spent in the shower each time you go. So we get 3 cents per minute, $0.03 per minute, and that's how we did it. 0.03. And this one, again, we didn't use all the information. We didn't use the number of bathrooms, but almost all the other information we did use. So let's keep going. Okay, so Dagago uploads 3 videos on his channel every month. Each video averages 15 minutes in length and gets an average of 150,000 new views. Wow, I wish mine did that. The average ratio of likes to views of Dagago's videos is 1 to 5. Dagago wants to reach a total of 9 million views on his channel. Assuming these rates continue, how many likes does Dagago get on average for each minute of video he uploads? Okay, here we go. This one's a doozy. So, assuming these rates continue, how many likes? And just to let you know, this Khan Academy, I've looked at this several times. This will ask different questions on the same set. So there's one that talks about, it'll ask you for what does the rate need to continue to get 9 million views? Okay, so how many months does he need to continue? So again, each problem can be asked a different way. So I'm only answering these questions, but this could be asked in a variety of ways. Okay, so assuming these rates continue, how many likes? We need to understand how many likes does Dagago get on average for each minute of video he uploads. How many likes does Dagago get? Okay, so we know that he gets 150,000 new views. Okay, so let's start there, right there. So we have 100,000 views. And then it says here that the ratio is 1 to 5, likes to views. What does that mean? So, oh man, I'm already at 10%. So likes to views, 1 to 5. So there's the likes, there's the views. Okay, so if he has 150,000 views, he's going to have 5 times less likes. So what we can do here is we can do 150,000, and we can divide that by 5. So 150,000 divided by 5, and that will tell us, divided by 5 because it's 5 to 1, 5 times as many views as we have likes. We can divide that by 5, and we can say that we have 30,000 likes for each one of his new videos, okay? But here's the thing. It's not talking about per video. It's talking for each minute of video he uploads. So if we know each video is 15 minutes, now we got to take our likes, okay, and we got to divide that by 50,000. So, oops, I'm so sorry, not 50,000. Where did I get that from? By 15. So this is per minute. So now we have the likes per minute, right? Assuming these rates, how many likes does he get for each minute he uploads? So 30,000 divided by 15, and I don't know if that's a good way or not. I'm not the right person to ask for that, but to me that doesn't seem like it's super intuitive. So if you divide 30,000 likes per video divided by divided by 15 minutes, per video. Then we get 2,000 likes per 1 minute of video. That's incredible. In my opinion, that's awesome. So let's go ahead and write 2,000 likes per minute. And I think we're good. Hopefully there we go. Nice. All right. Rosalind is driving to visit her family who live 150 kilometers away. Her average speed is 60 kilometers per hour. The car's tank has 20 liters. This is a great road trip problem. At the beginning, and its fuel efficiency is 6 kilometers per liter. Fuel costs 60 cents per dollars per liter. What is the price for the amount of fuel that Rosalind will use for the entire drive? Okay, that's a great question. I actually do this a lot in some trip planning. One of the best applications of math. So let's make sure we get this right. What is the price for the amount of fuel that Rosalind will use for the entire drive? Okay, so 150 kilometers is the distance that we need to travel. Okay. Her average speed, I don't think we need to know her average speed at all, okay? If we're just trying to find the amount of fuel, then we could probably just forget about that because it's only kilometers per liter. It has nothing to do with per hour. So we can just get rid of 60 kilometers per hour. Again, there's information we don't use. Each one of these questions, this is one of those. The car's tank has 20 liters of fuel at the beginning of the drive, and its fuel efficiency is 6 kilometers per liter. I don't even think we need how many liters are in the tank, okay? Because we just need what is the price for the amount of fuel that we'll use. She might refill it or whatever. It doesn't matter, okay? We don't need to know that there's 20 liters of fuel at the beginning. We just want to know how much is to use. So 6 kilometers per liter. So we have 6 kilometers per 1 liter, okay? Now, since we're only worried about the price for the amount of fuel, okay, then we should probably just convert this liters into dollars. Fuel costs 60 cents per liter. So to go 6 kilometers, we spend 60 cents. Okay? And then we're going to go a total distance of 150 kilometers. All right. So you can see here I'm trying to set something up. You can see I put kilometers on top, kilometers on the bottom. Sorry. Kilometers on top and kilometers on top. These need to be equal, right? And then over here we have dollars. Whoops. Over here we have dollars. Okay. And then I want to know how many dollars I end up spending on the whole trip. And this rate will continue. Okay. So for some value of X is going to give us our cost for going that 150 kilometers. And we know that each 6 kilometers will spend 60 cents. So it's just a proportion, and we're going to cross multiply and solve for this. This is probably the easiest way to do this problem. So as we do it, we're going to do 150 times 0.60. We could just put 0.6, and this is going to be equal to 6x after I cross multiply. So let's simplify the left side here. I have 150 times 0.6, and I get 90 on the left side. So we get 90 on the left side equals 6 and then x, like I said. We need to divide by 6 to solve for x. So we do 90 divided by 6. That should give me 15, and it does. Okay, and what is this information? Okay, that tells us that we spent $15 to go 150 miles because this rate continues, right? If we're talking about extending these units and these unit problems and using rates, well, that means that we're going to spend $15 on the whole trip. It doesn't matter how many liters are in the tank. Doesn't matter how fast we drive. If this is the rate, it will continue. Then that's the answer. So we're going to go 15 here, $15 for that trip. And we got it. Boom! Happy about that. All right. So I hope you enjoyed this video. Don't be shy to request anything. I may take a while. It's been just a busy time right now for me. But this is my commitment to you guys and to this channel. I hope you I hope you enjoyed it, like I said, and make sure to check out other videos like this. If you need another request, make sure to leave a comment. I look forward to seeing you next time right here on Wes Explains Best. Stumbled through that one.